In 1993, Professor Philip Johnson of the University of California at Berkeley invited a group of scientists and philosophers to a small beach town on the central coast of California. They came from major academic centers, including Cambridge, Munich, and the University of Chicago, to question an idea that had dominated science for 150 years.
I think Pajaro Dunes represented a turning point for many of us. Individually, we all had questions about evolutionary theory, but when we came together, each person brought something of their own to the table, and suddenly we all had a glimpse of a new way of looking at life that none of us had individually seen before.
I would have to say that this was an intense period of time in my life. It just seemed that there was something here much more intellectually satisfying than the view that I had held up until this time.
Looking back on it now, I think that gave me the motivation to actually look at the evidence and just see where I thought it pointed.
I realized that this was bigger than any one person or discipline, and this was the beginning of a community of scientists who were now willing to face the fundamental mystery of life's origin.
I sometimes wonder why anybody talks about anything else, because this is the most interesting topic there is. Where do we come from? How did we get here? What brought us into existence? What is our relationship to reality as a whole?
You look at the incredible diversity and complexity of life, and inevitably the question arises, what brought all this into existence? Was it simply chance and necessity, undirected natural forces? Or is there something else going on? Is there a purpose, a plan, a design due to an intelligent cause? I think that is the fundamental question.
The scientists who came to Pajaro Dunes set out to re-examine the mystery of life's origin, for each had significant doubts about widely held evolutionary ideas. Among them, biochemist Michael Behe questioned how natural processes could have assembled the intricate structures found within living cells. Dean Kenyon was an evolutionary biologist who no longer thought that chemistry alone could account for the origin of life on Earth. And Stephen Meyer, Paul Nelson, and William Dembski were seeking a new approach, one that could explain the origin of the genetic information encoded in living organisms. These scientists and philosophers began to formulate an alternative to the central theory of modern biology, a theory born in the mind of a British naturalist. His name was Charles Darwin. In 1831, Darwin, then 22 years old, set sail on a 5-year survey expedition for the British Empire. He journeyed from England on the HMS Beagle, traveling around the southern tip of South America, then north toward a chain of volcanic islands in the Pacific called the Galapagos. On this desolate archipelago, 600 miles off the western coast of Ecuador, Charles Darwin encountered an extraordinary array of birds, reptiles, and mammals, the likes of which he had never seen before. For more than a month, Darwin studied plant and animal life, took extensive notes, and collected specimens. Then he left, never to return. 25 years passed as he developed a theory about how the diverse forms of life on Earth had originated. In 1859, Darwin published a book titled On the Origin of Species. Its impact on science and ultimately all of Western culture was dramatic. Darwin argued that all life was the product of purely undirected natural forces, time, chance, and a process he called natural selection.
For 2,500 years before Darwin, most prominent scientists and philosophers, people such as Plato or Newton or Kepler, viewed the world as the product of some kind of design or plan. But a fundamental shift occurs with Darwin's idea of natural selection, and a real change in scientific philosophy is set in motion.
Darwin was not the first scientist to propose a theory of evolution, but he was the first to offer a plausible naturalistic mechanism that could produce biological change over long periods of time. To understand how natural selection works, consider the finch populations Darwin encountered on the Galapagos Islands.
13 species of finches inhabit the Galapagos Islands, and they vary subtly in terms of their body size and shape of the beak. Darwin returned to England with 9 different species of these birds.
According to contemporary Darwinian theory, differences in the sizes and shapes of the birds' beaks are the direct result of natural selection. One example often cited involves species of seed-eating finches. Following seasons of heavy rain, small, soft seeds are plentiful throughout the islands. Birds with short beaks can easily gather food. However, during periods of drought, the only seeds available are encased in hard, tough shells that remain on the ground from the previous year. In these circumstances, only birds with longer, sharper beaks can crack the shells and eat the seeds.
Those birds with the longer beaks survive because they can reach the food source, whereas other birds cannot. That long beak, then, confers what biologists now call a functional advantage. The finches with smaller beaks, unfortunately, die out from starvation because they cannot reach that food source. If the drought conditions continue, the environment causes a change in the features of the finch population as a whole. Over time, the long beaks are passed on to succeeding generations because those beaks enable the birds to survive.
Natural selection was a powerful idea. Physical variations that proved advantageous would be inherited by succeeding generations. Through this process, populations would be altered, and over time, fundamentally different organisms would arise without any form of intelligent guidance.
Darwin wanted to explain everything in the history of life in terms of undesigned, unintelligent natural processes. And when he looked for an explanation, what he found was that a process he could observe in domestic populations also operates in the wild. Now, Darwin himself was very familiar with domestic breeding. He himself studied pigeon breeding. And he knew that for centuries, human breeders had been able to make dramatic changes in populations by selecting only certain individuals to breed. Darwin really suggested that this same process operates in the wild.
For Charles Darwin, natural selection explained the appearance of design without a designer. There was no longer any need to invoke an intelligent cause for the complexity of life. In effect, natural selection became a kind of designer substitute.